We've looked at systems of equations. We've even looked at 3-variable equations. And we could see that with a 3-variable equation, it became a little more difficult in order to solve that system. There was very many steps. And we don't want that to be our capping point of we can only solve 2-variable, 3-variable systems. We need to be able to solve any given system that we encounter. So what's going to help us with this is something called a matrix, and specifically an augmented matrix. So let me set this up for you. What is an augmented matrix? It's a matrix. You'll see it noted with brackets. And what this is going to do is you're going to take all your coefficients in your system and set them up with all your x coefficients going here, all your y coefficients going here, your z's here. Sometimes we put a big dark line here, and then these are all of our constants. And so it's a very compact way of writing a system. You can see that all your variables do have to be aligned. And so to make this make a little more sense, that was very general, let me write these two following systems as an augmented matrix. What you do is you set up a squared off bracket. We're going to write the first equation. -3 is our x, -2 is our y. We can put a straight up and down bar here, and then 9 would be your constant. You can see they're all horizontally lined up, but they are only the coefficients of that system. Now we can also look at the next piece, which is going to be a 5 for our x, a -5 for the y, and a -40 for the constant. Now, if they are, again, you can see that these x's are lined up, y's are lined up, constants are lined up, and this line right here we create is our equal sign. So if we don't have them already lined up, we do need to take those steps and do that. Here's our 3-variable system over here. So what would this look like in an augmented matrix as a startup setup? Here would be my equal sign. So that means 15, 12, -6, so I'm just lining up all my x's, -10, -11, +4, 1, 2, -1. There is an assumed 1 on these values, -38, -40, and 17. Now, if any of these did not exist, what we could do was to just put a 0 in there. So say you didn't have a z in one of those equations, you just put 0 as a placeholder. Now what's going to happen is you can see, and if you notice from your notes, your 3-variable system, that's actually the one I have set up for you here. So what we want to be able to do is to take something like this and change it into a form. So manipulate the matrix per se. And what they do is we take this system and we input it as a matrix, and it actually can give us out some results. So the next word that I want to write down in vocabulary for you is a row reduced echelon form of a matrix. And what that does is it takes this matrix, it does operations, addition, subtraction, scalar, like all these different operations that we're used to doing in a very general sense, and it does it to this matrix. What it creates is ones along the diagonal. And so instead of having all those coefficients, it creates ones. Put a little bit of extra zeros there. There we go. And then what happens on the other side of it, where we have this line, is it gives us our value. So it gives us what is x equal to here. Let me use not a letter x. It gives us 3 different values here, and they correspond to the one that was placed. So remember, this was our x row. So this is telling you x would be equal to this value over here. This is our y row. So it means your y value would be equal to over here. And this is our z row. So whatever z is equal to, it'll be equal to this value here. Now, what we're going to do, because we can see when we're working that system, there's lots of steps to it. What the matrix does is it does everything kind of behind the scenes. And so what you're able to do is input those values and able to get a result a lot quicker than you would if you were using all your systems for solving. And so let's look at that previous example that we have. I'm just going to roll down here. This came from our solving in 3-variable. We said x minus 3y. Make sure I copy it correctly here. And that solving by 3 variables, we had 15x minus 10y plus z equal to negative 38. I'm just copying on my system. 12x minus negative 11y plus 2z equal to negative 40. Negative 6x plus 4y minus z equal to 17. And we worked on how to solve that system. So let me show you how the matrix is going to work out nice for you. First thing you're going to do is you're going to set up a matrix. And so maybe let's make some steps along the way. So step number 1, you're going to create an augmented matrix. And so for this example here, I would say, well, that would be 15, 12, negative 6, negative 10, negative 11, 4, 1, 2, negative 1. Here's what my equal sign is, negative 38, negative 40, and 17. Now, when we're writing them out on paper here, I am signifying that dark line as your equal sign to show you how that works. What we're going to do next is we're going to go into our calculator, and I'm going to give you a link to a matrix calculator and show you how this works. So step 2 is you're going to create the matrix in the calculator. And how I'm going to show this to you is I want to walk through the notes of the step, and then I want to go to the on-screen matrix calculator and show you those steps there. So what you'll do is you'll create this matrix, we'll call it capital A, and you will just input everything we just did here. Again, you're not going to do that line straight up and down there, but you will have the same values. After you create your matrix in your calculator, you're going to use a command called RREF of your matrix A. What it will result in is like what we were talking about here. It's called row reduced form of it, and it will give you zeros on the diagonal showing you what is x, y, and z. So in this case, it gives me a value of negative 11, negative 99 over 13. Excuse me. Not negative 11. It's going to give me a value of, we've already worked this, negative 1, 2, and negative 3. And this is just signifying, remember this is your x, y, z roll, that your x is equal to negative 1, y is going to be equal to 2, z is going to be equal to negative 3, just like what we solved when we were solving that system of equation. So I want it to write out these steps. How are we going to take a really large system and solve it? We're going to create our matrix, put it into the calculator, and then use this command here of RREF. So let's see what that looks like on the calculator. Let's see how that 3-variable system is going to work on our matrix calculator. This is a resource that will be given on your homework and if it's needed on an exam. So the first thing we're going to do is create a new matrix that's going to automatically label it A. Then you want to create the correct amount of rows and columns that you will need. Input, we've already written that down on our paper, so we're going to input all these coefficients into here, just like what we wrote on our paper. I'm just entering all the coefficients in order. I've got my row of x's, here's my row of y's, my row of z's, and my rows, and then I'll do my row of my constants. Just using my minus sign to create that negative if I need it. So now I have matrix A defined just like I saw in my system, all correct. Make sure you have all your additions and negatives correct in there. Then what you're going to do is you're going to use this button right here, your RREF. Now you're not going to have to input your matrix again. You're just going to use the A to represent that matrix. You can see that it has already outputted the answers that we were able to achieve by solving that system. So this RREF is going to be really nice in solving large systems. You have to input the matrix. I would suggest writing it down like we did on step 1. Enter that as matrix A and then use that RREF. Again, it's in this bottom left-hand corner. And again, this resource will be given to you on the online homework and if needed on the exam.